All right, let's go through the semester one final exam review. So the first question is, can you explain gas pressure in terms of movement and the collision of gas particles? And the question, the specific question is, people who have difficulty breathing are sometimes required to use a highly pressurized oxygen tank. Explain what's happening at the particle level inside the tank to create the high pressure. Gas particles are in constant, rapid motion. They move in straight lines until they hit a wall or another particle and change directions. Inside the tank, particles are colliding with the walls, and they exert force over an area, which is the definition of pressure. And it's always nice to have a little picture to go along with something. So let's say this is my tank. We've got gas particles moving around, colliding with the walls. Next one. Gas particles in 10 milliliters of space are exerting a pressure of 100 kPa when suddenly they're given double the space. Assuming the number of gas particles and the temperature are constant, what will the new pressure of the gas be and why? Draw a picture. So when gas particles are given more space to move around, they collide with the walls less often, therefore exerting less force over an area, therefore exerting less pressure. Since the gas particles have double the volume, in this case, their pressure would be cut in half to 50 kPa. Okay, so we've got 10 milliliters of space, let's say. And moving around, let's draw 4 of them. And then all of a sudden they have 20 milliliters of space. You can just see they're more spread out, so they're not going to collide as often with the walls. So here, this would be 100 kPa, and this one would only be 50 kPa. Gas particles in a flask at 273 Kelvin have a pressure of 70 kPa. If the temperature decreases to 250 Kelvin, will their pressure increase or decrease? Their pressure will decrease when temperature decreases. The average speed of the particles also decreases, which results in less collisions with the walls of the flask, which means less force over area, decreasing the pressure. Okay, so we've got a flask, got gas particles inside. Okay, this is 273 Kelvin. This is 70 kPa. And then all of a sudden, it gets colder, goes down to 250 Kelvin. Particles I'm going to show just moving more slowly, and so the pressure would be less than 70 kPa. Gas particles in a balloon have a volume of 4 liters when their temperature is 300 Kelvin. If the temperature of the particles in the balloon increases to 350, will the volume of the balloon increase or decrease? Assume the number of gas particles in the balloon and the pressure remain constant. So, in order for the pressure to remain constant, if the temperature of the particles inside a balloon increases, the volume must also have increased, because when temperature goes up, particles move faster and would collide with the wall more frequently, unless, of course, the walls are flexible and expand, which means the particles now have to move further and collide with the walls with the same force over area. So when the particles speed up, they push out against the flexible walls of the balloon, causing the volume to increase. We can show a balloon with the particles inside. Okay, this is 300 Kelvin, 4 liters. And then we're going to need to show it bigger because at 350, they're moving faster. So the volume must have gone up in order for the pressure to stay the same. Okay, moving on to Unit 2. A lake has a surface area of 8.25 kilometers squared. Assuming the surface area remains constant, if a glacier with the following dimensions completely melts into the lake, how much will the level rise in meters? Okay, so let's figure out what the volume of the glacier is. So it is, let's see, I guess I can just type this into the one-note calculator. 259 times 0.034 times 0.0041. We'll keep all the significant digits for now, and that's kilometers cubed. Okay, we know volume is kilometers cubed, so volume is 0.0361. And we know the surface area is 8.25. Volume divided by area, which would be kilometers to the third divided by kilometers to the second, that's going to equal the height of the sea level rise in kilometers. So we need to do 0.0361 divided by 8.25. And we should have, there's 2 significant digits on these and 3. So our answer should have 2. So that kind of comes out perfect. And this is 0.0044 kilometers. We want to get this into meters. 1 kilometer is equal to 1,000 meters. So we're multiplying by 1,000. That comes out to be 4.4 meters of sea level rise. All right, recording the measurements. So this instrument goes 40, 41, 42, 43, 44. It goes by the ones place, and it's between 43 and 44, but we estimate out one more, and this looks like it's right on the 43, so I would do 43.0. This one, 8, 9, it goes by ones, but we would estimate out one more, so maybe we would do 8.9. We don't know the units, but both of these would go to the 10th place. You have a piece of metal that has a volume of 2.5 and a mass of 29.0. What's the density? Density is mass in grams divided by volume in milliliters. 29.0 grams divided by 2.5 milliliters. And then we're going to need to do two significant digits because 29.0 is 3 significant digits and 2.5 is 2. So then we would round this to 12 grams per milliliter. That would be my final answer. That would be the density of this piece of metal. Next, dimensional analysis. You measure the height of your laptop screen to be 212 millimeters at its longest point. How many feet is this? Show your work using dimensional analysis. Okay, so let's see. We can get millimeters into centimeters. 10 millimeters, we want millimeters to cancel out, is equal to, it's a sideways equal sign, 1 centimeter. We know we want centimeters on the bottom now because we want that to cancel out. We want to get this into inches. 2.54 centimeters is equal to 1 inch. Centimeters cancels. And then we've got 12 inches. Inches cancels out. 1 foot. So our answer is going to be in feet. Now we multiply everything on the top. 212 times 1 times 1 times 1 divided by everything multiplied on the bottom. 10 times 2.54 times 12. Okay. So this is 212 on the top. On the bottom, we've got 10 times 2.54 times 12. These are exact numbers, so we don't use significant digits. Until the end, we want to compare it to this measurement, which has 3 significant digits. So let's see, I'm going to do 212 divided by 304.8. Answer, 0.696 feet. Perfect. I was just like, is that right? Sometimes I check myself. 212 millimeters in inches in feet. Yeah, perfect. Okay. Next, you need to be able to look at a graph, and if it's mass versus volume, well, the slope is change in y over change in x, so that means the slope is equal to the density. And we've got y equals mx plus b. The slope is the m, so the slope for this one would be 1.09 grams per milliliter. It's as easy as that. Okay, next, describe what happens at the particle level from the before picture on the left to the after picture on the right. Okay, so the red particles have a higher amount of thermal energy and are in contact with the white particles, which have a smaller amount of thermal energy. When the red particles collide with the white particles, the red particles slow down as they transfer some energy to the white particles, and the white particles speed up as they receive energy from the red particles. Eventually, all the particles reach thermal equilibrium and are all moving at the same speed. Okay, one of these problems. Object A has a mass of 20 and its initial temperature is 150. Object B has a mass of 10 and it's 0. So when these two objects touch each other, what is their final temperature going to be? Okay, so I just saw it wants me to put tables in this. Let's do it this way. The mass ratio of A to B is 20 to 10, which is 2 to 1. The change in temperature ratio is going to be the opposite. It's going to be 1 to 2. But it's 150 degrees difference, 150 to 0. So what is a 1 to 2 ratio within that? So let's add 2 plus 1 is 3. Let's do 150 divided by 3. It's 50. So that means it'll be 50 to 100. So 50 to 100 adds to 150, and it's a 1 to 2 ratio. What that means is that the change in A will be 50, and the change in B will be 100. So the final temperature will be 100 degrees Celsius. B will change temperature by 100 degrees Celsius, and A, because it's bigger, is not going to change temperature as much. And temperature is 50. Okay, equal masses of antimony, which has a specific heat of 0.21 calories per gram degree Celsius, and aluminum metal, a specific heat of 0.92 calories per gram degree Celsius, are both heated with 100 calories of energy. Which has the greatest temperature change? Why? The antimony would have the greatest temperature change because it only takes 0.21 calories to change its temperature, to change 1 gram of it by 1 degree Celsius, while aluminum takes a lot more energy to change 1 gram of it by 1 degree Celsius. Using the equation, how much heat transferred to 75 grams of water if the temperature went up from 12.2 to 9.5? Reminder, the specific heat of water is 1. Show all work and round to the correct number of significant digits. So our mass is 75 grams. Our specific heat is 1. And we need to figure out our change in temperature. It went from 12.2 up to 91.5. So I need to subtract. Change in temperature is 79.3 degrees Celsius. So grams are going to cancel, Celsius is going to cancel. We're going to have our answer in calories. 75 times 1 times 79.3. And we want to round to 2 significant digits. So 5,900, of course. It's not too bad, actually. 5,900 calories. All right, next I can apply the heat of fusion. The amount of energy needed to melt ice is 80 calories per gram. And in this problem, it says, how many calories would it take to melt 4.1 times 10 to the 16th? Okay, so what this problem is saying, it takes 80 calories. Oops, let me try this again. It takes 80 calories to melt 1 gram of ice. And we're trying to melt 4.1 times 10 to the 16th grams. So it's going to take a lot. Okay, so let's see, 80 times 4.1 times 10 to the 16th. 3.3, 2 significant digits, is that right? Yeah, 2 significant digits. 3.3 times 10 to the 18th calories. That's what that E means, times 10 to the. Because grams cancels out, and we're left with calories. All right, some more recent things. Circle the correct answer. Sodium is an element. It's on the periodic table of elements, and it's in period 3. It's in group 1A. And another element similar would be something in its same up and down group. Sodium is to the left of the zigzag, and it belongs to the alkali metals. That's the name of group 1A. Okay. Nitrogen is an N. It's atomic number 7. So that means it has 7 protons and 7 electrons if it's neutral. The average atomic mass, I think, is 14.01, which means rounded to the nearest whole number is its most common mass number. So the number of neutrons in its most common form would be the mass number minus the number of protons. So still 7. It would have 7 positively charged protons in its nucleus, and it would have 7 negatively charged electrons outside the nucleus. Next is barium. It's number 56, so it has 56 protons and 56 electrons in its neutral form. Its average atomic mass is 137.33, which means it rounds to 137. And let's do some math here. 137 minus 56 is 81 neutrons. It would have 56 positively charged particles in its nucleus and 57. Oh, sorry, I'm making up stuff. I looked at the 7. 56 outside its nucleus. Oh no. Phosphorus is number 15. Sorry, I'm just doing the answer key to make sure that I don't have any mistakes in here. So this is definitely a mistake. It'll be fixed before you guys get it. I don't think I've pushed it out to anybody yet. No, good. Okay. How many total electrons does phosphorus have? Well, it's number 15, so it has 15. How many shells does it have? 3 shells, and it's got 5 in its outermost shell because it's in group 5A. So the number of shells matches the period number, and the number of valence electrons matches the group number. Rubidium, number 37. It's in period 5, so 5 shells, and group 1A. Oh no, am I in the wrong one now? Of course I am. Sorry, worst video ever. Okay, I think we're back on track here. Which of the elements, sulfur or argon, has a smaller atomic radii? This one is missed by people quite a bit. Sulfur and argon both are in period 3, so both have 3 shells of electrons. Argon would have a smaller atomic radii because it has 2 more protons than sulfur. Protons have a positive charge and attract the electrons, pulling the shells in a little tighter, making it a little smaller. So if I were to draw a picture of this off to the side, sulfur has 16 positive protons, 3 shells of electrons. Sulfur has 18 positive protons, also 3 shells of electrons, but notice I'm drawing them a little tighter because those positives, since there's 2 more, they're pulling in those shells a little bit closer. Which of the elements would have a larger ionization energy? Argon would have a larger ionization energy, which means it takes more energy to remove an electron because they both have 3 shells, but argon has more positive protons in the nucleus, pulling the shells tighter and having more attractive force pulling on those electrons. Name any element that would react similarly to sulfur. Anything in group 6A, because they have 6 valence electrons. That's why they would react similarly. They all want to gain 2. So number 8, oxygen, for example. Isotopes. There are 3 common isotopes of carbon, carbon 12, 13, and 14. Based on that information, which of these is the most common? Well, on the periodic table, carbon's square says, carbon's number 6. Its average atomic mass is 12.01. So that means that carbon 12 is the most common. Because this mass number is closest to the average atomic mass for carbon, 12.01. Okay, please complete the following table. Fluorine, I just have this memorized, as number 9. And the dash 20 means its mass number. So for number of neutrons, we need to subtract 20 minus 9. It's 11. Chlorine, it's number 17. And then 36 minus 17 will give us the number of neutrons. 19. And number 19 is potassium. So this would be potassium dash. 19 plus 21 is 40. And its symbol would be K with a 19 and a 21. Fission and fusion both release energy. Fission is when you have a larger nuclei and it gets split. Fusion is when you have two small nuclei adding together to form one larger one. Fission has radioactive products. Fusion, non-radioactive products. They're both used in nuclear weapons. You could probably come up with more. All right, alpha, beta decay and fusion. Alpha decay always loses an alpha particle, which is the same size as a helium nucleus. So we need to subtract. So this would be 238 plus 242 minus 4, and then 92. And then we need to look up the new element that number 92 is, and it's uranium, because I just know that one. Beta decay, the mass is always the same, and the bottom number goes up by 1. So number 11 is sodium. You can use your periodic table up here to find out which atomic number it changes to. And the last one, fission, I like, not fission, sorry, fusion, because you just add them together. 2 plus 2, 1 plus 1, that now is a helium. You could come up with so many for one benefit and one hazard related to nuclear chemistry. I'm just going to put answers vary. Example, one benefit is nuclear power. Great green source of energy. One hazard is how to dispose of the radioactive waste. Takes a long time to decay until it's safe. Okay, 1 mole of lithium has a mass of about what? Well, if you look at lithium square, it's like average atomic mass is 6.97. So what that means is 1 mole of lithium atoms weighs that many grams. What's the molar mass for Be and BeF2? Be is 9.0122. And F is 19. So for BeF2, we need to do 9.0122 plus 19 times 2. So I'm going to use my OneNote calculator. And then 38 plus 9.0122. So this would be 47.0122. We don't round molar masses. These would both be grams per mole. Which has more atoms? 10 grams of lithium, which weighs 6.97 grams per mole, or beryllium, which we just found weighs 9.0122. Well, lithium atoms are a little bit smaller. So if you have 10 grams of each, that must mean 10 grams of lithium contains more atoms because lithium atoms are smaller in mass than Be atoms, so it takes more Li atoms to reach 10 grams. Okay, let's do some converting here. You got 29.8 grams of sodium. How many moles is that? Well, you can look up on the periodic table how much 1 mole of sodium weighs. It says it weighs 22.99 grams. So next we multiply across the top and divide by the bottom. 29.8 times 1 divided by 22.99. 3 significant digits. So this comes out to be 1.30 moles of Na. If you gargled 0.55 moles of NaCl in a cup of warm water, how many grams is that? Well, how much does 1 mole of NaCl weigh? Na is 22.99, Cl is 35.45. So we need to add that up to get the total molar mass. That's 58.44 grams. Multiply across the top, divide by the bottom. Answer, 2 significant digits, 32 grams of NaCl. Bonding. Ionic bonds involve a transfer of electrons, while covalent bonds involve a sharing, and metallic bonds involve a sea of electrons. Okay, and then there's that nice little flow chart which tells you that if something is a metal, like number 22, that it's going to have metallic bonding. If something has a metal to the left of the zigzag and a nonmetal to the right of the zigzag, that will have ionic bonding. If something is a gas, that's a dead giveaway that it has molecular covalent bonding. It's a molecule. And nonmetals that are a hard solid, that's network covalent. Will solid copper sulfate conduct electricity? Well, let's see. This is a metal and nonmetals. So no. Ionic substances do not conduct as a solid. Will it conduct aqueous? That means dissolved in water. Yes. Explain. Oops. Let me see if I can type. It's not going to let me. Okay. Ionic substances are soluble and do conduct as a solution. Name a property that NH3 gas would have. Well, this is molecular covalent bonding. So we can list some things off like a low melting point, doesn't dissolve or doesn't conduct electricity. Those would be 2 good ones. Would each of the following gain or lose electrons? And write the symbol. Well, potassium is closest to number 18, argon, so it would lose 1, and it would form K+. Magnesium wants to be like number 10, so it wants to lose 2 electrons. and it will form Mg2 plus. Bromine wants to be like number 36, krypton, so it wants to gain 1 electron, Br minus. Oxygen wants to be like number 10, neon, so it wants to gain 2, O2 minus. And phosphorus wants to be like argon, number 18, so it will gain 3 electrons. Name 3 elements that would combine with oxygen in a 1-to-1 ratio. Oxygen wants to gain 2 electrons to be like neon. So perfect matches are elements that want to lose 2 electrons, like number 4 Be, number 12 Mg, number 20 calcium. One of these group 2A elements would satisfy 1 oxygen atom in an ionic bond. -2 plus a +2 equals 0. Neutral. When magnesium and nitrogen combine, they form Mg3N2. Explain why they combine in a 3-to-2 ratio. Mention what is happening to the electrons. Gotta fix that up real quick. I forgot I wrote on this too. Sorry, okay, there we go. So magnesium has 2 valence electrons because it's in group 2A. So let's draw these guys. We know there's going to be 3 of them because that's what the compound tells us. Nitrogen has 5 in its outer shell in group 5A, and it wants to gain 3 to be like neon. So 1, 2, 3, 4, 5, 6. We're going to have Mg2 plus, Mg2 plus, Mg2 plus for a total of +6. And we're going to have N3 minus, N3 minus for a total of -6. So that's why 3 magnesiums and 2 nitrogens make a perfect neutral compound. Okay, let's write some formulas. Copper 2 chloride, that means copper has a +2 charge. Chlorine, if you look up its charge, it's always a -1. So that means it's CuCl2. Nickel has a +3. Se, if you look it up, it's always a -2. So when you crisscross, it'll be Ni2Se3. Lithium is Li. Nitrate is NO3, one of the polyatomic ions. So this will be LiNO3. And manganese +4, nitride -3. So this will be Mn3 when I crisscross, N4. I'm just switching the places of those. Okay. How would I name CuF? Copper, Roman numeral 1, fluoride, because fluorine is always a -1 if you look it up. Okay, next, this is potassium carbonate, because it's one of the 6 polyatomic ions. Then we've got lithium sulfide, because we always change the ending to "ide." We've got calcium phosphate, This is one of the 6 polyatomic ions. NH4, also one of the 6, ammonium iodide. And nitrate is always a -1 charge. So if iron is canceling out 3 of them, that must mean this must be iron 3 nitrate. There you go.